Okay, so this problem define the function to be tangent xy times sine 1 over x squared plus y squared plus 5 e to the x plus y whenever x, y are not 0 at the same time. And when x, y is 0 at the same time, it's a. Alright, and the question asks you to find the limit of g, x, y as x and y go to 0. So we ignore this part because as x, y goes to 0, it's not really 0, it goes to 0. So we use the first part. So the question just asks you to find the limit of this guy as x, y goes to 0. And the first thing you notice is like, this part has no problem because e to the 0 plus 0 is e to the 0, which is 1. So the problem is with this part. So we investigate more closely. Tangent xy times sine 1 over x squared plus y squared. Right? So the first thing you try is you plug in numbers. Tangent of 0 is 0. Tangent of 1 over 0 is bad because 1 over 0 doesn't exist. So you need to find somewhere else to solve this problem. And the thing you say is like, this guy go to 0 as xy go to 0. This guy is crazy, but it's not that crazy because sine of anything is bounded between minus 1 and 1. Right? So when you see something go to 0 and the other thing bounded, you think squeeze theorem. So what you do is, you say sine of 1 over x squared plus y squared bounded between 1 and minus 1. Right? So you say the function that you're interested in is bounded between what? Tangent xy and minus tangent xy. So you just multiply this equation through by tangent of xy in order to get the function that you're interested in. And now you see the middle guy is the function that you want to find the limit. It's bounded between two other functions. Both of them go to 0 as xy goes to 0. Therefore, the limit of tangent xy sine 1 over x squared plus y squared is also 0 by squeeze theorem. So it's 5, and the reason 5 is the answer to part A is because so the limit of xy go to 0 is 0 plus 5 e to 0 plus 0, which is 5. The second part asks you to find A such that G is continuous at 0, 0. Right? So we define this function this way, and the first part we just use the top part. We ignore the second part, and the second part show up in the second part of the problem. So when you look at this problem, this should remind you of one variable case. So you can have functions like this, right? Where like there's no value of the function at, let's say, x equal to 1, but the limit exists. So in order to make this function continuous at 1, you can define g x to be fx when x not equal to 1, and the limit of fx as x goes to 1 when x equal to 1. This way, the function will be continuous. So, in this case, what you want to do is you want to define g00, 0, which is a, to be the limit of this guy. So, g00 0 has to be the limit of xy as xy goes to 0 of gxy. Right? And g00, 0, you look at the definition, g00 is a. And the limit of the function as xy go to 0 is, oh, I forgot the first part, is phi